Class. In this video, I'm going to go over various evidence-based instructional models. So this week, our objectives are to define evidence-based instructional strategies or models that can be used to support the learning of diverse students, and then design standards-based instructional strategies that meet the needs of diverse students. So in this video, we're going to be going over some of those instructional strategies and models that we found in our readings and what they look like, and I'll provide you some examples and how we can use them to support those needs of diverse students. So throughout the course, you have been building a lesson plan week by week. We started in week one where we identified a standard, or was that week two? Sorry, week two, where we identified a standard and we broke it down into know, um, know, understand, and do objectives. So as you were doing that, we took a standard, we broke it down into smaller objectives. When we move on from there, you wanted to pull one of those objectives, most likely a do objective that you're going to develop that lesson plan around. From there, we created an assessment that we can use to assess students on that standard and objective. And this week, we're looking at how we can include strategies that are aligned to not only that standard and objective, but also, what strategies are there and what models can we use to teach our students? All right, so what are evidence-based instructional strategies? So evidence-based instructional strategies are essentially research-based instructional strategies that have been researched and have been proven to support students with learning. And so we want to use evidence-based instructional strategies because the research shows that when we use these strategies, they support student learning. And that's always our bottom line as teachers. We want our students to learn. So the first instructional strategy that we are going to talk about is direct instruction. So direct instruction is probably the most common strategy, and you have all experienced direct instruction in your own educational career, and it's one that you probably are the most familiar with. So it is an instructional model used to explicitly teach targeted knowledge, skills, or both. And so in the direct instruction model, it is essentially an I do as a teacher, watch me, then we're going to do it together. So you can do it with guided support, or we call it guided practice. And then you do. So it's that gradual release of responsibility where you show how you do it together, and then you release them to do it independently. Now, in the direct instruction model, this is a great way for you to teach a specific skill or specific knowledge where you want students to really see how it's done first before they engage in doing it. So one example I have of that, here's my objective. When you see SWBAT, that stands for the student will be able to. As I was developing objectives in my career, we always were told to write it in that form as SWBAT. So that's just my practice on how I write my objectives. So the student will be able to use context clues to find the meaning of unknown words. So for that objective, we know that the students need to learn how to use the clues within a text to help them find the meaning of unknown words. So I might model this for my students, and I could model that by reading a text or a part of a text in with my students, and I might model for them coming to a word that I don't know, and I might think aloud. Thinking aloud is a great strategy that we use during direct instruction and say, I don't know what this word means. I'm going to read the sentence again and see if there's any clues in this sentence that'll help me understand what this word means. And so I might model that with one word in maybe the first sentence or two in our reading. And then as we're reading, we'll read maybe the next sentence or two together, and we would do a we do together where we come to a word that we don't know the meaning of it, and then we'll together do that same activity where we're going, are there any words in this sentence that help me understand what this word means? and we'll do it together rather than me just modeling it. And then I would release the responsibility to students after they've practiced maybe a couple times with that guided instruction, and then they're going to have to do it. And maybe I would have them underline an unknown word that they found, and then what words in the sentence help them understand that word. And so the direct instruction model is really the one that we're probably most familiar with. This is the model that many teachers use for almost every lesson. But there are other models that teachers can use, and we're going to keep going into those. All right. So the next model we have is a concept attainment model. Now, this is a great instructional strategy for when you are learning a new concept or kind of like a big idea or big concept that we're trying to focus on. So the steps for the concept attainment model is essentially you want to first name the concept that you want students to understand, and then come up with a definition or a rule. And then you're going to think of those attributes that that concept has. And then you'll give examples of the concept, and non-examples are also included within those examples. And then you'll think about that relationship between the concept and other concepts. So this could be done with scientific concepts or different ideas with social studies. This wouldn't be something that maybe I used all the time in something like just something very basic as like we're learning addition right now or we're learning subtraction right now. This is more of like a bigger idea that has some examples, some non-examples, some rules and definitions. So a math example I might use is geometry. Geometry has a lot of concepts and a lot of vocabulary. And one is polygons, and another is quadrilaterals. And so here you can see I have a standard over here, which shows a third grade standard. I know that because it's got the 3 in front of it, and then it's geometry. And it's understanding that shapes have different categories, such as rhombuses and rectangles. They might share attributes, such as having 4 sides, and their shared attributes can define a larger category, such as quadrilaterals. So this standard is all about this idea of quadrilaterals and looking at the subcategories. So my objective that I wrote for this is students will be able to classify shapes by common attributes and identify the name for the category of shapes. And so this is a good one to use for concept attainment. Whereas I don't know if just basic word problem standard would be good for this specific standard. So you really have to understand what's a big concept if I'm going to use this model. So let's go ahead and look at my example here of the concept attainment model. So first name the concept. We're going to learn about polygons first. And then a polygon, the definition is a plane figure with at least 3 straight sides and angles, and typically 5 or more. And so that was a definition I just pulled off the internet. But some of those conceptual attributes, so the concept attributes is they actually need to be straight lines. It needs to be a closed figure, and it's a plane figure. And so it has to have 3 straight lines because if I had 2, it wouldn't be a closed figure. And so here, for examples and non-examples, step 4, here are examples of polygons, and here are examples of not polygons. And so with students, I might talk about what makes this a polygon and what makes this not a polygon. And so here we can see this is actually a 3D figure, not a plane figure. So that's why this is not a polygon. This one is not closed. This ends up being like 2 connected polygons, or this one has an extra line segment. So you can see that some of these are examples and non-examples, and some of them are regular and irregular. A lot of times we look at regular polygons just like a equilateral triangle or a perfect pentagon like you see over here. But we can have irregular polygons as well, where we have one, two, three, four sides on this shape. And so that would make it a quadrilateral, but it doesn't look like maybe your typical quadrilateral. So the concept attainment model really is great with larger concepts that you're trying to teach, but it is not the best strategy for all things you're teaching. So you have to choose when to use this one wisely. And how does this help our diverse populations? Well, let's think about this. We're mapping out a kind of hierarchy or relationship between concepts. Like you can see here, once I found polygons, we're now breaking down into triangles, quadrilaterals, and other types of polygons. And so students are starting to see connections between things. And the more connections that we can make, the stronger understanding that our students are going to have. All right, the next one is concept development model. Now, concept attainment and concept development models sometimes get confused and interchanged. So in this one, it's all a little bit different, and it's really an inquiry-based model, meaning it doesn't include this direct instruction like we saw in our first. We want students to explore first, and we teach after explorations. So the first step in the concept development model is listing as many items as possible associated with a subject. So just kind of like purging and brainstorming. And so at this point, there's no teacher modeling going on. We're just saying how many different animals can we think of? Then you're going to sort items into categories. And so you're not sorting per se, have the students sort. And when we sort, do an open sort. Don't tell them how to sort them. Just tell them, I want you to sort your animals into different categories. And they're going to come up with different common attributes. And you're going to have them then label what that category is. Maybe it's animals with fur. And so they would label this is animals with fur. Then you're going to say, okay, now that we have those different, could we group them a different way? And so then they do another sort where they're sorting it in a different way. And then at the end, they kind of summarize and generalize some of their understandings that they have. So when students look for patterns and find commonalities and differences between things, it helps them understand a concept at a deeper level. When they have to make a generalization or a summarization, it helps them kind of tie all of that information together in one cohesive statement. So for my example, we have a first grade because it has a number 1 in front of it. Always look for your grade level. First grade science standard for Arizona. And this standard says develop a model to describe how animals and plants are classified into groups and subgroups according to their similarities. So the objective I wrote here is just exploring how animals are classified into groups and subgroups. And we're not quite at the developing model yet. So when we think about our standard and objective connections, our standard is the large learning target for quite a few things. And our objective is what they're going to learn in one day or over the course of maybe 1 to 2 days. And so it's going to be a smaller chunk. So you'll notice I don't have plants in my objective because I wouldn't want to teach both of those on the same day. They're not at the point where they're developing a model yet. They're just exploring how they're classified into groups and subgroups. So it's just a smaller chunk of learning. So when we think about those connections between standards and objectives, think about this as one day of learning, and this is a larger learning target that we are trying to get to by the end of a unit or the end of several days of learning. So in the concept development model, it's great to use with things that have a lot of things associated with subjects. So science is great for this. Social studies is great for this. Um, I could do this with some geometry and math and and even some data analysis I could probably do this with. In reading, I might use this with some vocabulary, but not reading comprehension per se. This wouldn't be a good strategy to use if we're learning how to find text evidence or um, find the meaning of an unknown word or things like that. And how does this support our diverse learners? Once again, we are finding patterns within a concept. We're finding commonalities, similarities, and the sorting requires students to be doing that critical thinking rather than you saying, students, there are different types of animals. We have mammals, we have reptiles, we have cold-blooded, we have warm-blooded, anything like that. Instead of you just giving them information, they're exploring that on their own and they're going, wait a minute, all these animals have fur. And you could say, oh, all these animals have scales. And you could talk about, oh, what do we call those categories? After they've labeled the categories and you've had some time to talk about those categories and regroup them, then that's when your teaching happens. So having students to develop that experience and make their own connections first only supports their learning at a deeper level. All right, let's look at the next model. There is a good video in your textbook that shows the difference between concept attainment and concept development. It's only like a 2-minute video, so it does a good job of explaining the difference between them. The next one's the integrative model. And this is a structured conversation that allows the teacher to focus on helping students acquire academic information while they're practicing reasoning skills. And so this model is developed around data sets. I would really highly encourage you to read the example in the textbook because it's kind of a complex and more advanced learning model. And so the steps for this are identifying a topic, and you're going to target some generalizations around that topic and a data set that you can use for analysis. So let's say in science, we're writing about the states of matter, solid, liquid, and gas. And so maybe my target generalization that I'm looking for around that is that temperature impacts the state of matter something is in. And so we have this connection. This is a generalization that I want students to understand. And so I'm going to create a data set or give them a data set that they would analyze. And maybe I would show like the temperature of water and then what's happening to it. And so when I have it at this temperature, we have frozen. And then when I have it at this temperature, it's liquid. And then I have it at this temperature, it's a gas. And maybe I will do that with several different state, different compounds or whatever it may be. And they'll look at this data set and allow them to notice. What do you notice about the data set? So put it in front of them. What do you notice? And they will come up with a lot more if you give them that chance to notice first before you explain it. Now, you do want to give them a context and explain background information. Boys and girls, we're looking at temperature of water and what happens to it when it's at different temperatures, and then allow them to look at the data. Then you're going to have them explain those comparisons, the contrasts, why it's happening. This is really great for social studies concepts, like they put the example in the book. And then they could hypothesize what would happen if it was under different conditions. And so when we have a social studies example, maybe we can see, like, for example, in rural areas, we had some population decreases when there was a drought. And so maybe we're finding that the reason the population was decreased in that area because there wasn't water or something. And so what would happen if there was water there? Do you think the population would still decrease? And then they would make generalizations. Students might generalize, oh, then people need to be close to water sources. And so when there's a drought, they might have to relocate or move or things like that. And so this advanced model is really around data sets and just students describing what they notice. Now, this wouldn't always be appropriate for every single thing you're teaching. I probably would not use this when I'm learning a explicit reading strategy or a explicit math strategy. But if I'm looking at data in math, that would be a perfect time to use this, or statistics and probability in our middle school standards. Those would be a great time to use data sets. Science, social studies are also great areas to do this. Now, how does this support our diverse learners? Well, first, any time I teach math or teach students a new model or use a data set, I always say, what do you notice about what you see? So they might look at a strategy. What do you notice? When I ask that question, it's a question that any student could answer no matter what level they're at. So an advanced student might notice some more advanced things, whereas a struggling student might notice just some basics, like I notice we have some numbers or some temperatures or things like that. And so the entry point on that first question is, what do you notice about the data set, allows for all students to interact with the data and be able to have something to say about it. Now, when students are looking at comparisons and patterns and things like that, that's requires some critical thinking skills, and it helps them make further connections. And so instead of me teaching students things like, well, if there's a water source near, people will stay. If they run out of water, they will have to leave. Instead of me direct instructing that, students are making those connections on their own. When they make connections on their own, they are more likely to retain and understand the information. And then again, those generalizations help them kind of summarize their learning and put a pretty bow on their learning for the day. All right, our next model is cooperative learning models. So essentially, cooperative learning is functional group work. And the big difference between just saying, hey, go work with your table or go work with a partner is that it's structured. We have structures in place to support students in cooperative learning. It does require planning. And so when you're planning for this model, first you want to develop clear instructional goals. Like, why are you putting students into a cooperative group to learn this? It could be something as simple as I want them to, define words and understand what they mean together, use the context clues together. So you want to have those instructional goals, and then how is it going to meet those goals? Consider the plan and the size and composition of your groups. Do I want to have them in pairs? Do I want to have them in threes or fours? Once we start getting larger groups, it's harder for you to manage. So you want to think about that. And then you want to make sure that the cooperative learning activity has the elements of cooperative learning. And so is that activity having all students participate? Are they working on solving a problem or doing a task together? And is there like a clear goal for them? Now, when you're implementing, you want to explain what the task is. Identify those social skills that are critical for the task for them to be successful. So you're going to have to talk. You're going to have to ask each other questions. You're going to have to take turns. You're going to explain those social skills they're going to have to use. And then I always model it for the students. So this is where a little direct instruction comes in. So I will model the first one for them. I might have a student come up and mock that we're partners together. And I would show how it would look for them to work cooperatively together and what my expectations are. So one of the strategies I used to use a lot is called a sage and scribe. And this strategy is a cooperative learning model where students have one paper and one pencil, and one person is the sage. So they are explaining what the answer should be, and the other person is the scribe. And so the other person writes the answers down, and then they switch roles. So if I was maybe doing a math problem, I might say, okay, one person's going to do the first step, and then the other person's going to write, and they're going to switch throughout that addition problem. And so when students are doing this, I might model that for them. So, okay, the first thing I'm going to do is I'm going to ask myself, can I subtract 3 minus 5? No. So I'm going to have to regroup. I'm going to go to the 10 place, and I'm going to take 1 from there and give it to the ones place. And then I'd have to pass the pen to my partner, and they'd have to do the next step. And so they're clearly having to communicate and explain what they're doing, and they're having to take turns. And so I would model that for students and tell them that. I have to tell my partner what I'm thinking. I have to say, I'm regrouping. So that students are then using the language, the academic language, and those social skills. While they're working, this is the teacher's time to walk around, monitor, provide feedback. It is not the time to get prepared for your next lesson or to check your email or any of that. It's really important that you walk around and support students because there will be disagreements, and you need to make sure you're managing behaviors or nudging students to communicate better or work together better. And then after they're done, you want to ask each group to summarize their learning, and you're going to evaluate learning and then assess the group process. So those are the 2 evaluations you're doing. So in my math example, I'm going to see, were they able to, regroup, or add or subtract whatever the goal was successfully? And then I would assess how they worked in groups together well. So were they able to communicate? Were they able to agree? Were they able to take turns and things like that? And so I would give them feedback on that in addition to the concept that they were learning. There are a ton of cooperative learning models. Um, Kagan, for example, is a company that provides professional development for teachers. So some of the structures that they have is they've just created different ways for students to work together. So we have like a round robin. In teams, they take respond orally, writing each response on their own paper. So they then, take turns and they respond orally. And so it could be like we're reading about time capsule or something, and well, I think the picture is about this, and I think the picture is about this, and they take turns in a round robin style. Another one is the carousel, and this is a feedback model, and so students might put their work up on the wall, and they go and they give feedback to each group individually. So they would you carousel, think of it like a carousel. So like small groups of four would go to the work that was posted and they would give them feedback like, oh, did you think about adding this into your writing? Or, oh, you might want to check your spelling. And then you'd say switch and they move to the next. Fan and pick is a model I really like using in math or with vocabulary. And you have cards that students fan out. So student one will fan the card, student two will pick and read the card, student three will answer, and then student four will tutor the person who's answering. And then you switch. Then the next person fans and they're a new student one and they pick the card and you keep rotating um, for that. Another one is find someone who, this one's really great when you're looking at someone who has certain skills or characteristics or a beginning of the year activity. Find someone who has the same birthday month as you. Or you could create cards, for example, with animals and characteristics. Find someone who also has the same, type of, I don't know, coat as you, like fur, Rottweilers. Find an animal that, and you could do whatever characteristics you're looking for. That one would also be great with geometry. So find somebody who has the same number of sides as you. Find somebody who has the same number of angles as you. And then find the fiction. This it's kind of like finding two truths and a lie. So finding out what's fiction. So you might give several truth statements and several one false statement, and you have to identify which one is false. And then inside outside circle. This is one where students are in an inside circle and they're facing out. The outside circle is facing in. And so they have a partner that they're talking to face to face. And then the outside circle moves over one and they have a new partner and it keeps rotating. I used to do this in my classroom and I called it a conga line. And so it was two lines and one line would move down and they'd have a new partner. And I did this with math a lot or grammar or things like that. So I would have a card with like a number on it and they would have to read the number because students really struggled with reading larger numbers. And then they switch cards and then the one dot line would move down and then they'd have to read their card and then they switch and then they move down and they would just do some really quick systematic practice of reading larger numbers or saying which number was larger or things like that. So if anything could be on your cards. And then I use those cards every year. I just had my large number cards. We use them and we might talk about, I would underline a number and say, what is the place value of the underlying number? Or I would say, read the number or whatever it was. And these cards could be used anytime. So those are just a few of the Kagan cooperative learning structures. If you ever have the opportunity to go to a Kagan training or get a Kagan book, I would highly recommend it. These are some of the strategies that I've used the most in my classroom, and they're great because they can be used for all subjects, just depending on what your goal is. So if I want students to get feedback, a carousel is a great strategy. This is also a great strategy at carousel for brainstorming, where it's maybe we have 4 posters with things I want them to brainstorm, and they write on the poster and add to or star other people's feedback or other people's ideas. So it just depends on what your purpose is and when you're going to use each of these different cooperative learning structures. But the key is that there is structure here. We're not just saying go work in groups, good luck. Because we know when we work in groups, if we don't give them expectations for what the students are going to do or how they're going to do it and what you expect of it, it can kind of get a little messy. And it can be where we have the dominating person who does all the work, the person who goofs off, or the person who checks out. And so by assigning roles and responsibility and really making it structured, it makes cooperative learning more successful. All right, so let's talk about the next strategy, which is inquiry-based learning. This is my favorite strategy. Inquiry-based learning is really based on the constructivist model or learning theory. And so constructivism is all about students constructing knowledge by interacting with the content or whatever it is, a question before any teaching happens. So the really important thing here, it's not just following the scientific method, for example. I mean, it can follow in that method, but it could be anything. It could be a math question. I can literally say, I'm going to introduce multiplication using the inquiry-based learning model. And I give them a question. Like I am having, um, I bought some soda for a party and I bought 3 6-packs. How much soda do I have for my party? And I can just say, here's some manipulatives. I want you to figure it out. And so I'm introducing multiplication without teaching them how to multiply. So first, they might come up with different ways. Some students might make, okay, this is my 6-pack and use manipulatives and draw it. Other ones might draw soda cans. Other students might go, well, if I have a 6-pack plus a 6-pack plus a 6-pack. So they come up with all these strategies before I've taught them how to multiply. And in that, then after we go over, after they explore on their own, then I following the 5E lesson plan structure, then I would explain, okay, you guys just multiplied. Did you realize that? Let's look at the different ways you multiplied. And so then I pull out the strategies that students used and I teach them. So, oh, you use manipulatives. You know what you did? You made equal groups. You used pictures. You also made equal groups. You added 6 3 times. We call that repeated addition. And I might create an anchor chart with these different strategies. And then I allow students then to go practice after I have taught. So in the inquiry-based learning, your teaching comes after exploration. And that's the most important thing for you to remember. It's great for science and math, but when I'm trying to explicitly teach a reading skill, like a phonics skill, sounding out words or things like that, it's not always the best for explicit instruction. Those really are better for direct instruction. Some things are better taught directly and explicitly, like some of our reading concepts, and some things like science and math are better taught by exploration. Now, there are different levels of student inquiry. And the first one is structured inquiry. This is really where the students follow the lead of the teacher and you do this all together. In my math example, that was more of a controlled inquiry. I chose the topic, I identified resources that they can use, and then I let them kind of figure out how they're going to do it. Now, in guided inquiry, the teacher chooses the topic and the students might design a solution or a product. My math example could go anywhere in between these two, but it's definitely not free inquiry. Free inquiry is the type where students choose the topics, they don't have any prescribed outcome, and it's really kind of a free inquiry classroom. This is less common in unless you're in like a really big a school where they're really into STEM education and they have students working on projects and solving their own problems. Think about maybe a science fair project, sometimes it's free inquiry, but in the classroom, I tend to see more controlled and guided inquiry. How does this support our diverse learners? Well, students who explore a concept first make more connections than direct instruction. So they are able to then conceptualize something on and explore it and critically think about it before they're actually taught. And then when they're taught, they have this background experience to anchor the new learning into, to go, oh, I didn't think about it as 6 plus 6 plus 6. I thought of it as a six pack, and six pack. But now that I've seen that, I can make this connection that that's the same thing. I just drew the six packs where you used the number. And so the more experiences our students have to anchor things into, the better understanding they're going to have. Now, I could have taught multiplication by saying, boys and girls, multiplication is making equal groups. Repeat after me, making equal groups. Watch, 6 times 3 means 6 equal groups of 3. I'm going to build 6 equal groups of 3. Now you build 6 equal groups of 3. Now, I could teach it that way, but students are going to remember and have more to anchor this idea into when you give them that inquiry-based instruction. So the inquiry-based instruction really requires the critical thinking of the student. I like inquiry-based instruction in math because math can be one of those things where if I do direct instruction too much, they're just copying my thinking. Teacher says we have to do it this way, and they copy my thinking, and they don't know why they're doing it, and they don't understand what the math really is. And so if I really want students to understand this idea of multiplication being equal groups, let them explore that idea first before copying my thinking. Copying my thinking is lower level rigor for students. So we want students to have a deep level of understanding, then let them think about it and have critical thinking on their own before we rob them of that opportunity. If we introduce it first, then they sit back and don't pursue their own thinking because you're telling them how to think, I guess would be the best way to say it. Um, vocabulary acquisition model is the last model we're going to talk about. And this is a model for learning meanings of new words. I wouldn't use this model in kindergarten or first grade. I think the lowest grade would probably use it in the second grade. And I wouldn't use this for everything. This is really when a word has oops, it says Greek or Latin roots. And you're really thinking about the meaning of the word parts and the spelling. And so if I'm thinking about an example that has Greek or Latin roots, I might be during measurement. So we've got the word meter, and I can add on some prefixes like millimeter, centi, or deci. And those prefixes help us understand that words. If I know milli means a million, then that helps me understand that there are a million per meter. Centi means 100. That means there's 100 per meter. So when we do this model, we first pre-test students on some of our words and what they mean, and they discuss their invented spellings and meanings. Then you go over the actual spellings and meanings, and this could be where they create a graphic organizer and they create their own vocabulary notebook or things like that, where you're going, okay, here's our word, here's some definitions, maybe some synonyms, some antonyms, what is our root, our prefix, our suffix, and then, like, what is this word in this sentence? Then you'll explore those patterns, like, oh my gosh, I didn't know, like, centi means 100, century, or percent, that means per 100. And so you look at those patterns and it helps you understand the meaning of those word parts. Then you assign some readings that create context for that. So now that we're reading about percents and century and all of that, then they have more context to anchor their learning into. And then finally, you evaluate their learning. So This model I would not use for my basic everyday words, but if I was introducing a new unit, let's say on measurement or on social studies with some of those complex vocabulary, I might use this model for that. How does this support our diverse learners? Our diverse learners really benefit from explicit instruction. Understanding these word parts will help them understand and open their mind to a lot of words. So if I learned about um, cent or century or percent, now whenever I see that word part, I'm going to better understand a lot more words than just that one that I was doing for our vocabulary acquisition model. So this really can open students' minds to these Greek and Latin roots and how they help us understand the vocabulary. As I said, I probably would not do this in a lower K1 early childhood classroom. The youngest I'd probably do this for is second grade. And definitely in third grade, we start exploring those prefixes and suffixes at a deeper level. So any grade above second, I think it would definitely be appropriate for doing this model. Now, in one of your readings, you had the 10 top-based evidence-based strategies. Let me just go over this graphic real quick for you. So first one is clear goals. When you are clear about what you want students to learn by the end of the lesson, and students know what they are expected to learn by the end of the lesson, you're going to see a lot better results because everything you do is aligned to that goal. So if I say that students are going to add and subtract and do word problems, that's not clear. That's way too much stuff for one day. What do we want to accomplish in this one day of learning? So maybe it's just addition word problems with regrouping or without regrouping. Be very clear on what you want them to learn. Now, once you have that clear goal, then you just line everything you do to it. I'm not going to teach addition, subtraction, word problems all in one day, but they've learned how to add. Now I'm going to add on the word problems. So addition with word problems. This is what I'm going to do. I'm going to limit it to 3 digits. We're not going to go above that. So the further I define my goal, the better my instruction is going to be because I'm going to align everything to it. We're going up to 3 digits, so I'm going to keep 4 digits out, maybe give some gifted students 4 digits. But my goal is that all students leave this lesson knowing how to do addition word problems with 3 digits, including regrouping and maybe not some without regrouping. Then the next one is the show and tell model. So this is just essentially showing and telling students or the direct instruction model or students instructing each other where they're teaching each other how to do something. Questions to check for understanding. So the teacher using questions as formative assessment. Summarizing new learning graphically, creating anchor charts to summarize what they learned. Practice, practice, practice. So allowing students to do the work, allowing students to practice. Remember, you already know how to do these things. We're trying to teach our students to do it. And so allowing them to be the one to engage in the practice. My favorite one is effective feedback. So based on the feedback I got from my mid-course surveys, students said that they are benefiting from video lessons and learning. And so I am changing my teaching practice based on that feedback that I got. And the same thing goes for you as students at GCU. You're getting feedback from your assignments from me, and that's to help you grow. And students need to know what they're doing well and what they need to improve on. In writing, they should have writing conferences. You should sit down with each student and tell them what they're doing well and what they need to improve on. Same goes for math, reading, all of these things. Students need feedback to grow. Being flexible on how long it takes to learn, knowing that my addition with regrouping might not be taught by the end of the day for all students. So I'm going to pull small groups tomorrow and the next day in math to support the students who still need more support. And then we have group work, like we talked about with our cooperative learning, teaching strategies and skills, so explicit teaching. So this is exactly how you do it. And then nurturing metacognition. So this is thinking about my own learning. And so we want students to think about, am I learning? Am I understanding this? And if I'm not, what do I need to do to help myself? And so, encouraging metacognition is I want you to think about your own learning right now. From a fist to five, how well are you understanding this concept? And so they might say five, I totally get it. Fist, I do not. And so getting kids to think about their own learning is a great practice. Now, it's not a great check for understanding because it doesn't tell me what students know and don't know, but it gives them that opportunity to think about their own learning. All right, so let's end with talking about supporting diverse learners. So when we think about diverse learners, we have several populations of students who need support. The first one is our ELL students. They need language support. Now, a lot of people's first inclination is to give them translations, give them translations. But when we look at our student profile for our class, if we see in that ELL column that they are a level 3 or a level 4, this means our students actually speak pretty good English. They just need academic language. Students at a level 1 are going to be our newcomers, our students who are just barely coming out of learning the language. They might not even speak it yet. They might need some translations, but most students are in need of more just English language support. They don't even know the translation in Spanish. Like if you're telling me states of matter in Spanish, I don't know what that means in Spanish or English. So translation isn't going to help students who need academic language support. And so when we think about supporting our ELLs, while translations might be helpful for our students at the very basic level at a 1 and a 2, it's not really an adequate support for students who are at a level 3 and 4, like our class profile shows most of the students are at. So what do I do to support these students? Give them word banks or picture word banks to help them understand the vocabulary that they need for that time. Give them sentence frames on how you want them to talk. So if I say, turn and talk to your partner about the meaning of independence, I might have gone over independence. I might give them a sentence frame like, I am independent when I, and then they could put, like make my own lunch or something like that. And so sentence frames really help students with using that academic language. Using hands-on materials will help them understand it when there are language barriers as well as visuals. Using smaller chunks of information and not being too, um, having breaks between your information. Here's a small chunk. Let's digest it. Let's talk about it. Let's make sure you understand it before moving on to the next chunk of information. And some of the strategies that they really support with their learning is that cooperative learning, direct instruction, inquiry-based learning, and getting feedback. Students on IEPs, typically in your regular education classroom, they are in resource class and they typically have processing and memory issues for those students. Now, students who are in a self-contained classroom, there's so many different classifications that I don't want to go down that road. But let's talk about our students in our regular classroom that are on IEPs that stay with you. First thing to think about is they still are responsible for learning your grade level standards. Their IEP goals are really about them um, working on specific skills with that teacher, but they still are responsible to learn your math and your reading. So it's important that you know that we can't just say, go work with the resource teacher. The resource teacher is working on her own goals or his own goals, where your goals are different. And so you need to make sure you support them in your classroom as well. Giving them less steps. So chunking it into smaller steps. So if it's a multi-step word problem, say, okay, I'm going to have you read the question and I want you to find what they're asking us and then walk away and then come back and say, okay, now that you've done that, and give them one more step. So we're chunking it into smaller steps. Giving them templates or note-taking kind of templates or things like that will help them. For example, if you're comparing and contrasting something, you might give them a template with like a Venn diagram to help them organize their information or a graphic organizer. In math, I've used it where students were learning like the standard algorithm for multiplying fractions. And so I created a template for the student that shows how we multiply fractions. And it's like kind of a step by step. They just fill in the fractions to help them step through those different things. Just like ELLs, they benefit from visuals and hands-on, direct instruction, cooperative learning, inquiry-based instruction. And as always, all students need feedback. For our gifted students, it's really a common thing for us to want to give them the low kids and say, hey, work with each other. You guys will help each other. But gifted students really want to challenge. They already know this stuff. They want to learn something too. So if they already know it, then we need to give them something a little more challenging. So you might give them more digits. For example, in our addition word problems, they might go to 4 digits or 5 digits and continue that same pattern. Without teaching from me, they might see if they can figure out how to do it um, in a in a different challenge. Or you might give them like a complex task to go solve. Like here you have all these items that you can purchase. You're going to go to the store and you have $500. You know, what are you going to buy? And with that off this list, they're very inquisitive. So let them be curious. Let's be curious and inquisitive and push their thinking a little bit. Allow them to go do some research or work on a project on their own or create, a way to teach it to other students. But they want to learn. They want to have a challenge. They get bored easy. And so if they're bored, then they get off task, and that often creates behavior problems. So if you give them a challenge, they will not be behavior problems typically. They love inquiry-based learning. They don't want to hear your thinking first. They want to figure it out for themselves. So let them figure it out. You might say, okay, here's some problems. I want you to go figure it out. Another strategy is giving them the hardest first. So if they can show that they can do the hardest problems first, then there's no need for them to do all the easy problems. Just do the hardest first. You've demonstrated your understanding. Now you can go work on that project. Give them enrichment activities, and keep in mind that they don't often enjoy tutoring. They really don't understand why the struggling learners don't get it because it makes so much sense to them. I often, if you're going to pair up gifted students, pair them with your medium high students, the students who are right below them. Pair your low students with your medium low students, so they're a little closer in their levels together. And then, as always, give them feedback. Everybody learns from feedback. That's one of the most important things that you can do to support your diverse learners. I hope this video helps you understand some instructional strategies and how you can employ them into your upcoming lesson plan. Be thinking about what your objective is connected to your standard. If you need to, refine your objective. If it's too big, it's not one day of learning, there's too many concepts, pare it down. Bring it down to one day of learning what you hope to accomplish in a 60-minute period. If you can't do it all in 60 minutes, it's probably too big. Then think about what learning strategies are going to be the best for this. If it doesn't have very much vocabulary, the vocabulary attainment model is not going to be a good learning strategy. If it's math, you might consider doing inquiry-based instruction to start it off so they can explore the idea first. If it's a reading concept, you might think, you know what, I need some direct instruction at the beginning because I need to explicitly model and do a think aloud on what it looks like. So be matching your objective to these different strategies and think about how you can support your diverse learners in your classroom. As always, if you have any questions, don't hesitate to reach out.